Okay, what we've got here is a quite difficult to understand two-dimensional representation of something going on in 3 dimensions. So first of all, if you read the question carefully, A, B, and C are all points on horizontal ground. So if you were looking at A, B, and C from above, then what you would have would be this. All 3 on horizontal ground. There's C, there's B, and there's A, and the distance from A to B is 40 meters. And the question asks us to find AC. Now, in order to find AC, if we could find the length of BC, in other words, this one here, we would be able to use Pythagoras' theorem to find the length of AC. And that's exactly what we're going to do. Okay, so we're told that C is west of B. In other words, this is a right angle. A is south of B, giving us the right angle again. AB 40 meters. This flagpole here is vertical, so it's coming directly upwards from B towards you. From A, the angle of elevation of the top of the flagpole is 13. So in other words, from here, from point A, the angle of elevation of the top of the flagpole, there's the flagpole, angle of elevation is always the angle which is made with the horizontal. So this angle here is 13 degrees. And we're also told that from C, the angle of elevation of the top of the flagpole is 19 degrees. So that means that this angle here is 19 degrees, the angle from the horizontal up to the top of the flagpole. And we've got the same flagpole. Obviously, there is only one flagpole. So what I'm going to do first of all is find the height of the flagpole. And in order to find the height of the flagpole, there's my flagpole, here's my right angled triangle. There's the flagpole there. This is 40 meters. This is 13 degrees. I can find the height of the flagpole. Let's call it x. And I'm going to label the sides then. This is the hypotenuse, the opposite, and the adjacent. So I'm going to use tan here. I don't want to know the hypotenuse. And I know that tan of 13 degrees is equal to the opposite divided by the adjacent. Well, that's x over 40. X then is going to be 40 times tan 13 degrees. And you can work that out on your calculator. It comes out as 9.234. 9.234. And I'm going to save that in my memory and call it A. So the height of the flagpole is 9.234. Don't round it at this stage. So I can put that onto this diagram as well, so 9.234. And what I can see now is that I can now use this triangle, so the triangle which has got the, so C here, B here. I know the height of the flagpole is 9.234. I know that this is a right angle because CB is horizontal and the flagpole is vertical. And I can now work out, if I know that this is 19 degrees and I want to find BC. Remember I said if I could find BC, then I could find AC using Pythagoras. So now, here's the hypotenuse. This is the opposite. This is the adjacent. Again, I'm not interested in the hypotenuse. And again, I'm going to use tan. So the tangent of 19 degrees is equal to the opposite, well that's the 9.234, divided by the adjacent. Well, let's call this distance here y. So CB I'm going to call y. Now, in order to find out what y is, I'm going to multiply by y. So y times tan 19 is going to equal 9.234. So y is just 9.234 divided by tan 19 degrees. And if you work that out, it comes out as 26.819. So 26.819. And again, don't round that number. Leave it in the memory of your calculator, or just keep it on your screen. Now, though, I know BC. I know the length of this. This is the 26.819. And if I now go up to this triangle, I can use Pythagoras' theorem. Let's say AC, so I know that this side, let's call it W. By Pythagoras' theorem, W squared, so the hypotenuse squared, will equal one of the short sides squared, so that's 40 squared, plus that 26.819, etc. squared. And if I work out the right-hand side there, it comes out as 2,319.29. And W is going to be the square root of that. So we square root 2319.29, etc. And that comes out as 48.159, 1590. So the length of AC is going to be to three significant figures, 48.2 meters.